Alright, so to tie chapter 4 together for you, hopefully make it a little bit more clear in your mind, I want to show you the following example. And this is supposed to show us, there's 3 problems here. You can see 1, 2, 3 on the side. And these are all 3 of the distributions that we talked about. So we should be using a binomial at some point. We should be using a geometric at some point. And we should be using a Poisson at some point. I'm also going to show you, we haven't talked about things like at least or at most for Poisson and things like that, so I will show you how to do those as well. Alright, so the problem says you only live once. It's quite a curious name for a safari company, but you only live once. Tanzanian Safaricon offers elephant rides with wild elephants. Because the elephants are untamed, they have a 52% accident rate, which YTS, meaning you only live once Tanzanian Safari, that's YTS. They euphemistically refer to these accidents as episodes. So every time an elephant, goes crazy and attacks a customer, they're calling it an episode. Okay, so we have to figure out for each of these problems which one should we use. Should we use binomial, geometric, or Poisson? That's often the most challenging thing in stats, is figuring out which type of problem am I supposed to be solving, because they're not always going to tell you, and that's the same in real life. In real life, they don't always tell you, hey, this is this type of problem. You kind of have to figure that out. So number 1 says the mean number of episodes per month is 4. Find the probability that in a given month, and this is the key phrase right here. Okay, it's not just, I know they're saying per month here, but this one says day and this one says day also. So all of them are referring to time. But the fact that they're asking you for probability in a certain unit of time should tip you off. And by the way, one resource I want to point out to you, this is in, it's not that one, actually this right here, this is in your textbook, and it's on page, let me just see if I can find this real quick. It looks like this is on page 219. It's a nice table that kind of summarizes all of these. So it summarizes what's a binomial, what are the conditions and the formulas, what's a geometric, and what's a Poisson. And it tells you, okay? It tells us about Poisson that we are being asked about the probability over a certain amount of time. So let's go back to ours. In a given month, that's over a certain amount of time. So this one should be a Poisson. Okay, and I will show you how to do that momentarily. Okay, but for now let's just figure out which is which. So the second one says if they offer 12 rides in a day, so you might say, well, day, doesn't that mean Poisson? Not necessarily. Find the probability that exactly 9 elephants have an episode. So in this case, this is a binomial, and the reason why is binomial is supposed to have 2 outcomes, success and failure. Success in this case is being defined as, I know, again, having an accident doesn't sound like it's successful, but that's how we defined it in this case. So find the probability that exactly 9 have an episode, okay? And the fact that they're asking exactly a certain number of successes, that is the tip-off that we're dealing with a binomial. Because if you look at this right here, we want to know, basically, I mean, they're not giving us an example, but it has a fixed number of trials, and we want to know the probability of having a certain number of successes. Okay, geometric, on the other hand, is asking us about repeating until the first success, until the first occurs. So the last one says if they offer 12 rides in a day, find the probability that the first episode, in other words, the first success, occurs on a certain trial, on the second or third. Okay, and then this is a little bit tricky. The first episode free ride occurs on the second or third. And then finally that the first episode occurs on the 10th. The 10th has an episode. So let me show you how to do each of these. Again, I encourage you to pause it and give them a try yourself before checking the answer. So the first one is a Poisson. So let's go to Poisson PDF in the calculator. Okay, and we want to know, right, this number is supposed to be lambda, and this number is supposed to be the number of successes. Okay, so the mean number is 4. That means lambda is 4. And we want to know the chance that in a given month they will be 6. That's exactly what you do. You do Poisson PDF with 4 and with 6. And when you do that, I'm coming up with this number. I'm getting 10.42%. Okay, let me just mention this because I don't think it came up in the prior one. Suppose they said experience at least 6. Okay, so in other words, 6 or more. Hopefully you remember from doing this before, at least means we're not supposed to be using PDF. We would want to use CDF instead, and that is right below PDF in the calculator. And let me show you how you would calculate that. So you go to Poisson CDF this time. Your lambda hasn't changed. Your lambda is still 4. At least 6, though, means that we want to find the complement. So this number right here should be all the numbers that go up to at least 6. And that would be, what's the opposite of at least 6? It could be 0, 1, 2, 3. I mean, the opposite of at least 6 is less than 6. So there are all the numbers less than 6, so I would put a 5 right there. Okay, so I will tell you what that turns out to be. Okay, this number right here, when you put this in, you get a number of 78.5%. That's not the answer, though. That is the complement. How would you find this? This probability that we just found, 78.5, that's the chance of getting less than 6. We want to find the chance of 6 or more. And that would be 100% minus 78.5%. Turns out to be 21.5%. So that is a chance that you'd have at least 6 episodes, meaning 6 or more. We know that to get exactly 6 would be 10%, but then 7, 8, 9, basically everything more would be that. All right, I'm going to clear this off because this is getting kind of messy. And then let's try number 2 right there. So number 2 says, if they offer 12 rides a day, find the chance that exactly 9 have an episode. We said this is a binomial, and it's not at least 9. If it was at least 9, we would be using CDF. This is exactly 9, so we want to use PDF. P stands for probability, C stands for cumulative. So the number of trials is 12 rides. The possibility of success, remember success is having an accident, so 52. And then 9 is the X value. So when you plug those numbers in, which I am doing off screen along with you, you will get an answer of 6.76% chance that would happen. Alright, so these last couple are slightly tricky. We have to read them real careful. Okay, we said this is geometric, and the reason we know is they're asking about the first success. When is the first success going to occur? On the second or third, so or means we're going to add. So I want the probability of the second or the probability of the third. Okay, and I'll show you how to do this. By the way, just so you know, when would you use CDF? Because we haven't done an example like that. You would use CDF for something like this. If they asked you, what's the chance that it occurs before the 4th, let's say. Before the 4th. So if you were given a question like this, you would go to CDF, and they're going to ask you 2 things. Okay, and I'll just verify what those are. So you go to Geom CDF, and it's going to ask you the p-value, which is 52%, and then this number is, well, before the 4th, means 0 or 1 or 2 or 3. So you would put right here, this number is supposed to be basically the chance of getting, this number is supposed to be the chance, like the highest number that you would go up to. So if you want it to occur before the 4th, it's going to occur on the 0th, or obviously the 0th doesn't make sense, on the 1st, the 2nd, or the 3rd. So you put a 3 right there. So before the 4th means it's going to occur up to and including 3. If that said before the 100th, you would put a 99 right there. Okay, that's not going to help us with this one though, because we want to know the 2nd or 3rd. It's not asking us before the 3rd, so we don't want to include the first time, only the 2nd and the 3rd. Okay, so we need to use Geom PDF, and for the first one, for the second one, first one Geom PDF, our p-value is going to be 0.52, and our x value is going to be on the second one. So you'd put this in for the first one. And then the second one, we want it to occur on the 3rd. So you add those 2 together, and I will do it along with you right now. So the first number that I'm getting here, this one, these different colors, so you can see it. This one, there's a 24.96% chance. And we do it on the second one, there is an 11.98% chance. So when you add those 2 numbers together, you get 36.94% chance of that happening. Okay, this one is a little bit tricky. The first episode free ride. So remember how they're phrasing this. They're saying there's success is getting in an accident. I mean, not literally, but according to how they gave us this. They told us the P is 0.48. Now we're being asked about not having an accident. So now let's change the parameters. Instead of having P be 0.52, what if there's a 52% accident rate, what's the chance that there's no accident? And that would be 100 minus 52, 0.48. So you basically have to do this exact same problem, but instead of using 0.52 here, use the chance of getting an episode free ride, of not getting an accident. So you plug in 0.48 there, and when you do that, you get 37.94%, similar to 36, but a little bit higher. Okay. Last one, this is the trickiest of all. What's the chance that the 10th elephant has an episode? So you might say, well, what formula am I supposed to use? Am I supposed to plug stuff in? No, you're not, because every single elephant has what chance of getting an accident? Every elephant has a 52% chance, including the 10th elephant. So the first elephant has a 52% chance of getting an accident. So does the second, so does the third, so does every single one. So this last answer is just 52%. That's the trick. Okay, it's not saying what's the chance of having an accident before the 10th or on the 10th. It's just saying what is the chance that the 10th, just the 10th, has an episode, and it's the same chance as every other, 52%. Okay, so that is just a summary of the different types of distributions. Hopefully it makes a little bit more sense. If it's not perfectly clear, continue to practice, and it will start to make sense as you do more and more of those.